Let's get this last example here. We're going to go over Fisher projections, okay, and then that'll conclude Wednesday's SI. Okay. So Fisher projections. Remember, Fisher projections are diagrams, again, kind of like Hallworth projections, where we're looking straight down on the molecule. Okay. So Fisher projections, I'm looking straight down on the molecule. And remember, if we want to put wedges and dashes in our Fisher projection, we can. Know that the arms of our Fisher projection, okay, are all wedges. All the horizontal parts are wedges. All the vertical parts are dashes, okay? That's just convention, that's how we write it in Fisher projections, okay? This is important to know that all of our side groups are wedges, okay? Pair that with this rule, okay? Remember, when our lowest priority group is a wedge, we need to flip that R and S orientation, okay? Okay, so we are going to go from Fisher projection into a line structure. Okay, we have our Fisher projection here. I am going to start out drawing a line structure based on my carbon chain of 1, 2, 3, 4 carbons. Okay, I have my 4 carbons. On my first carbon, I have a carboxylic acid, okay? Okay. Notice each carbon in my Fisher projection that is designated by a cross is a stereocenter. It has 4 distinct groups. My carboxylic acid does not. It does not get its own cross in the Fisher projection. Nor does this carbon here get its own cross because it has 2 hydrogens on it. So my last carbon there is bonded to 2 hydrogens and an OH group. And again, it doesn't matter the stereochemistry on this OH group because it is it's not bonded to a carbon that's a stereocenter. Okay? If I look at carbon 2, I have an OH and a hydrogen. I can put that in OH. I have an OH down here. Okay. This is the basic structure of my Fisher projection. Okay? It does not show, however, stereochemistry, R and S configuration. Okay? That's what we need to do as our final step here. Okay? Now, I would recommend just guessing. Okay. Let's whether these are going to be wedges or dashes or not. Okay. We can only know, going from Fisher to our skeletal structure, we can only know if that's the right stereochemistry by making sure the R and S are consistent. Okay. So let's designate the R and S of each of our stereocenters, carbon 2 and 3, on our Fisher projection. Then what we'll do is we're going to add dashes or wedges to our OH groups, and they can be whatever we want, and we'll test the R and S configuration, and if they match, then we know we have the right structure. If they don't, we can just change a couple things around, be all right. Okay. So let's do R and S configuration of this Fisher projection. Pause the video and try it on your own. What's the configuration of this carbon atom? Use your priority groups. Remember, our hydrogens are dashes or wedges here, okay? So we're gonna have to flip the orientation. Try it on your own. What is R and S for our Fisher projection? Okay? Cool. Welcome back. Glad you got that. I am going to designate my first priority group. I have a carbon here that's bonded to a carbon, an oxygen, a carbon, and a hydrogen. Oxygen being the highest, it's gonna be my first priority group. My hydrogen being the lowest will be my 4th priority group, okay? I have a tie between this carbon and that carbon, okay? My top carbon is directly bonded to an oxygen twice with a double bond, okay? And another oxygen directly bonded, 3 bonds to oxygen, 2, to the top oxygen and 1 to my OH group down here, okay? This carbon down here is bonded directly to an oxygen, a carbon, and a hydrogen. My first point of difference is a carbon versus an oxygen. Our oxygen being a higher priority, it's a larger atom. This is going to be my second group because oxygen is larger than carbon. This will be my third group. Now if I go in the order of 1, 2, and 3, notice that I'm going counterclockwise. I am going in S configuration, okay? Normally this would be S, but notice my fourth group is in a wedge, okay? So I'm gonna flip that. Now I'm going clockwise. I'm going with a right turn. This is an R configuration, okay? Carbon 2 is R. Okay? If you didn't quite get that, try it again with carbon 3. Pause the video, use what we just did, try carbon 3. Is it S or an R? You got a 50-50 shot, okay? Let's go ahead and try carbon 3 now. Again, I'm directly bonded to an oxygen here, so that's gonna be my first priority. This hydrogen will be my fourth priority. And again, I have a tiebreaker between my carbons, okay? My top carbon is directly bonded to, in order of highest to lowest, an oxygen, a carbon, and a hydrogen. My carbon down here is directly bonded to an oxygen with the OH group and then 2 hydrogens. Where's my first point of difference? It's in my carbon and hydrogen here, okay? My carbon's gonna win up top. This is gonna be my second group. This is my third group. Again, I'm going in a counterclockwise direction first, 1, 2, 3, but I'm gonna flip it because my hydrogen is in a wedge, okay? So normally I would be going in S, going in S. I have to flip that because my lowest priority group is a wedge. So now I'm going R. This is also R configuration, okay? My Fisher projection tells me that both of those are R, okay? Now, all I have to do is go over to my skeletal structure. I have the actual structure, okay? But to know I have the right stereochemistry, I need to make sure these are also both in R configuration. Whether that's a wedge or a dash, I don't know. What I do is I just guess. I'm gonna make them both wedges. Okay, I'm just gonna make them both wedges. If I make them both wedges, I know my lowest priority group, my hydrogens, are gonna be dashes. I won't have to flip anything, okay? So, this carbon and this carbon are the same. This is carbon number 2, okay? This is carbon number 3 down here. Let's start with carbon number 2, okay? R and S configuration. Pause the video, try it on your own, okay? Welcome back. My OH group is going to be my first priority, okay? My hydrogen that's not drawn in is going to be my fourth priority, okay? That hydrogen there, that's number 4, okay? Now again, my tiebreaker is going to be carbon, carbon. This has 3 bonds to oxygen, this has 1 bond to oxygen, and lower atoms. This will be number 2, this will be number 3. I will go in a counterclockwise position. This currently is an S. Oops, must be a wedge. Sorry, it's currently a wedge, it's an S, okay? We know that our Fisher projection made it R. What do? We change our OH group into a dash. Notice when I do that, the connecting atoms to my carbon are all the same, okay? So this is still going to be my first priority, this is still going to be my second priority, this is still going to be my third. But now that my hydrogen is a wedge, I have to flip that. And now, instead of going counterclockwise with S, I have to flip it because my lowest priority group is hydrogen. Now we are in R conformation, which matches what we had in our Fisher projection. So we know carbon 2 is a dash, okay? Use what we just did on carbon 2, pause the video, try carbon 3, and see what you get, okay? Is a dash gonna work? Is a wedge gonna work? Go ahead and try it out, okay? Let's start here. Our first priority group is gonna be our oxygen, okay? We are bonded currently to a hydrogen and oxygen and carbon chain, 2 carbons, so oxygen will get the first priority. Hydrogen will get our 4th priority. Now between our carbons, okay? This carbon here is bonded to an oxygen in descending order, oxygen, carbon, hydrogen. This carbon is bonded to in descending order, oxygen and 2 hydrogens. Where's my first point of difference? It's right here in my carbon and my hydrogen, okay? This side will get higher priority. This carbon will be 2, this carbon will be 3. I am currently going in an R configuration, okay? Notice I'm going clockwise, 1, 2, 3, clockwise. My hydrogen is going away from me, which is good, in a dash. I don't need to change anything, 1, 2, 3. This is currently an R, we don't need to switch it. Now we know we have the exact same structure over here in our Fisher projection as we do our skeletal structure, okay? These problems can take a little bit, but as you get more used to with priority groups and stuff like that, hopefully that will get better, okay? Rewatch that if necessary. I know that's I did it kind of quick, but it's good practice, I think, between Fisher and skeletal structure, okay? Now, here's another example. You can pause the video now. I don't even know if these are right or not. I'm gonna erase these in case they aren't. I just drew them in, just because, again, you just guess. But here is a Fisher projection, okay? Go ahead and try and convert this into a skeletal format, okay? I already have it written out here. Okay. Take this Fisher projection and turn it into a skeletal format, okay? Pause the video. Cool, try it on your own. See how far you get. All right, let's go over the answer here. Real quick, I see 1, 2, 3, 4 carbons. I see I have an OH group connected to this carbon here with 2 hydrogens, don't need to draw those in. I have an OH here, and carbon 2, and a hydrogen. Same thing on carbon 3, OH, okay? And then my last carbon, I have a nitrogen bonded to it, okay? I'm just going to write, I'll draw it in like this, okay? So, 4 carbons, I've drawn in all my connections. Now I need to worry about stereochemistry. Notice this is not a stereocenter. I only have 2 groups, right? A nitrogen and a carbon. Notice this is not a stereocenter because I have 2 hydrogens on here, same group, okay? I have 2 stereocenters on carbon 2 and on carbon 3. Okay? Let's start with the R and S configuration up here. Remember, what's going sideways are wedges, okay? So we're gonna have to flip these because the hydrogens are on the side. My first priority group here, again, is going to be the one directly bonded to oxygen, my highest group. Hydrogen will be the lowest. Okay, I have a decision to make between these 2 carbons here. This carbon is bonded directly to, in descending order, an oxygen, a hydrogen, and a hydrogen. This carbon is directly bonded to an oxygen, a carbon, and a hydrogen. This one's higher priority. This is 2, this is 3. I will be going clockwise, okay? I'll be going clockwise, that is R configuration, but wait, I have a wedge here on my hydrogen. So I need to switch my R to S. Carbon 2 is S. Use what we just did in case that's confusing. Watch it again. Go ahead then and try carbon 3 and see what you get, R or S, okay? Okay. I have my carbon here. My first group, again, is going to be the one directly bonded to oxygen because it's the highest, it's the largest atom that we're directly bonded to. Hydrogen is going to be lowest. I have a decision to make here. I have a carbon. Bottom carbon is connected to nitrogen 3 times. Nitrogen, nitrogen, nitrogen. This carbon is bonded to oxygen, carbon, and hydrogen in descending order. Now, which is better, 3 nitrogens or an oxygen, a carbon, and a hydrogen? All you need to do is look for the first point of difference, okay? So ignore, just look at them one at a time in order. That's why we put them in descending order, okay? Nitrogen or oxygen, which one's larger? Oxygen, okay? So although maybe all of these together seem larger, we only look for the first point of difference. So because my oxygen is larger to this carbon here that it's bonded to, rather than this nitrogen, this is going to be my second group, okay? Oxygen is larger than nitrogen. This carbon down here will be my third. I am going in counterclockwise here, 1, 2, 3, but because my hydrogen is a wedge in a Fisher projection, not explicitly drawn, but trust me, it's a wedge, we're going to flip that. This is R, okay? Normally we would be going S, we flip it because hydrogen is a wedge. Now we're going R. We're going right-hand circle, we're going the right way, we're going clockwise, okay? So we know this up here needs to be S, our carbon 2, and we know carbon 3 needs to be R. Let's start guessing. Let's start guessing. Pause the video, guess, draw a wedge, draw a dash, okay, and then test it out. If it's not, just change it, okay? So throw in a wedge or dash wherever you want. I'm just, again, gonna use wedges. That way my hydrogens are dashes, and I don't need to switch anything off the start, okay? First priority group here is, an oxygen, okay? Hydrogen's gonna be 4. Carbon, oxygen, carbon, oxygen, hydrogen. This is gonna be number 2. This is gonna be number 3. I am going in an R configuration here. 1, 2, 3, okay? This needs to be S. Right now it's an R, that's not good. That must mean that this is actually a dash. Notice my priority groups will stay the same, only I have to flip the orientation because my hydrogen is now a wedge, okay? Last one. Carbon 3 here. First priority group, what's it gonna be? Our one directly bonded to oxygen because it's larger than carbon and hydrogen. Our hydrogen is going to be our 4th group. Tiebreaker again between our carbons here. I have a carbon directly bonded to an oxygen and a carbon directly bonded to nitrogen. Oxygen is larger, so this carbon will be our second priority group. This will be our third. We are going currently clockwise, okay, which is good. We wanted R configuration for number 3. We are currently going that way. This is R, this will stay a wedge. This is the correct structure of our Fisher projection into a skeletal format. Okay. With R there, S there, okay? You can also go from skeletal projections and make your own Fisher projections. So we're not gonna do that now. This video is already longer than I want it to be. But yeah, this should cover Wednesday. Hopefully you're a little bit better, feel more comfortable with R and S configurations, both in a Fisher projection and a line structure assessment. She's gonna ask you, what's it on? You know, it's just RS configuration, okay? Convert this Fisher projection to line structure. So, good practice there. Again, just to recap, we went over identifying chiral centers. We talked a little bit about chirality here. What's achiral? What does meso mean? What does chiral mean? Again, we identified chiral centers there. I didn't get to this rule. I will on Monday and Tuesday. Really all this is, I might as well go over in class, but this shows you N being the number of chiral centers on how many different stereoisomers you can have, how many different enantiomers or diastereomers you can get total. So for example, if we have 3 stereocenters, 2 to the third, there's 8 possibilities here that we could have. 8 different stereocenters, different diastereomers or enantiomers and stuff like that. So, we went over R and S configuration. We talked about flipping when our lowest priority group, not always hydrogen, but usually when that is in a wedge, okay, that we need to flip R to S, S to R. We looked at Fisher projections, kind of talked about visually what they mean, and then converting those to our skeletal format, checking S and R configuration, okay? Hope that was helpful. Thank you for watching or attending SI on Wednesday. So, yeah, I'm gonna post this early. I believe it's Monday now. I think I started the video Sunday. I think it's Monday now. And yeah, hopefully I'll see you all at SI this week.